Guys, please confirm to me. All of you get my voice on screen. Those are attending in online. Guys, please confirm to me. All of you get my voice on screen. Those are attending in online. Am I audible? Please confirm to me, guys. All of you get my voice on screen. Those are attending in online. Am I audible? Guys, please confirm to me. All of you get my voice on screen. Those are attending in online. Am I audible? Nandro. All right. Good morning, guys. So, right, sir. Now, check it what we are discussing actually. So, I think so. We are discussing about thread life cycle. The topic we are discussing there. In what happened? Think your seats, the total correct batch are sitting in front of me now today. Huh? All most intelligent people are sitting in front of me today. Now I'll ask questions to you, ready for it. All right. Coming to the point, thread life cycle, we are understanding the collective information of a thread right from its born state to the dead state is called thread life cycle. Okay. So in Java applications, every thread will have the following life cycle stages. What are the various life cycle stages are available for a thread? No. First one is new or born state, runnable state, running state, blocked state, dead or destroy state. These are all like different states which are available for the threads. Understand it now. Okay. Now I want to show that all the states information by taking a diagram. Understand this diagram here. When a thread will come to the new or born state, I'll give some points to you. Now, first of all, this is like what there, new or born state. Okay. When a thread will come to the new or born state, if you observe this, when we create thread class, that thread may be user defined thread class or maybe predefined thread class, that doesn't matter. When we create thread class object, automatically the thread will come to new or born state. Clear? Just it's a matter of welcome thread, WT is equal to new welcome thread. Object I created. Automatically the thread is in what? New or born state. Clear? Next one is runnable state. Next state is what there? Runnable state. When a thread will come to the runnable state, understand it here? Only one situation. When a thread will come to the runnable state, understand it now? When we access start method, understand one point. When we access start method over the thread, internally system resources will be assigned. What are the system resources? No, a bit memory and some timestamp. Execution time and memory both will be assigned to the thread. Then when the system memory and execution time both are assigned to the thread, automatically that thread will come to the dead state. Sorry, the thread will come to the running state. When it will run, see the point is what? If it is a running race, for example, all the participants will take the positions or not. Understand it? When their names are announced, participants' names are announced, that is newer bonus stage. When they're coming to the positions, they will take some position in a specific position. They will stand there, right? About to release, about to start. They will take some positions. That is exactly runnable. They're waiting for the signal from the umpire. If umpire is giving whistle, immediately the people will start running. Am I right or not? Now, before the point is what there already names are announced, competition was started there, that time was not assigned, but people are ready to run. People are ready to run, but signal was not available. Exactly, that state is what they're runnable, means that they're able to run. They're able to run, waiting for the resources. What is that resource? No, waiting for the signal. If time is started, immediately they will take run. Immediately they will start to run. Am I right or not? So that state is nothing but what the runnable state. Now observe carefully. When we access start method, okay. Now instead of saying that when we access, after accessing start method, and before getting system resources like memory and execution time. The state of the thread is what their runnable state. Everybody understand the point here, what I am telling to you know? The start method, just we called. After accessing start method and before getting system resources like memory and execution time, the state of the thread is what their runnable state now. Right. When it will come to the running state, when it is coming to the running state, now just a small change in the statement. What is the change in the statement about this running state? No, after accessing start method and after getting system resources like memory and execution time, after getting system resources like memory and execution time, automatically the thread will come to what state there? Running state. In the same example, running race example, when the person has given whistle, immediately that all the participants have taken track or not, have started their running or not. Now that is running straight now. Understand it clearly. Okay, fine. Now it is in running. Observe carefully, running straight now. Now, when we access stop method, for example, the time is completed. The time, whatever the time we assigned for a particular race now, the time is completed. Then everybody must be in relaxed mode or not. Everybody must stop their running or not. Understand it clearly. So that state is what is a dead state or destroy state. We can understand either of the things, no? Dead state. Okay. That state is what there? Dead state. When we are able to get a thread in a dead state, no, we can understand when we call stop method over the running thread. When we access stop method, automatically the thread will come to what state there? Dead state. Don't think about it directly from dead state to again new or born state. No. Once the thread is in dead state, no, then that object must go for what their garbage collection only. Understand my point or not? The thread is again will not come back. It will not take born state, the same thread. Thread in the sense, don't think about the object. Thread in the sense, what their flow of execution. I get my point on. Thread is what their flow of execution now. The flow of execution is a new or born state, runnable state, running state, dead state. Right, sir? When we call stop method, when the thread execution is completed, automatically the thread will come to what their dead state. Once it is in dead state, no, it is not possible to come back. A person is died. Is it possible to get the same person again? Understand it now? But don't go for the movies and stories now. Magadira movie or some other movies now. Then I'm not talking about it. It is a nonsense. It's practically not possible. Are movies they are giving some different shades now. I think one movie I've seen in Telugu, I remembered every time now. Actually, that hero might be is a scientist actually, is going on to some planet there. Okay, but previously was involved in some other mission. That mission was failure. Might be that rocket might be in some other place there, some other planet is surrounding there, rotating there at some other location. But he's for some other mission is traveling. In the middle of the journey, anonymously he's changing that plan. What I'm telling that plane to what, that means the rocket to what there, some other planet. Initially they're programming for one planet. Later on they're changing to other planet. Is it possible? Everything will be operated from ground, right? That centers, right? Respective centers, no. But what is that movie, sir? I think that movie name I forgot it now. Hero is Varun Tej, I think so. Antariksha. Right. In the middle of the journey, he will change that plan. They will go to some other planet, not to the original planet. No. Then how it is possible? Even in the planet also, that flight is all option crash landing is going on, but hero and that everybody is safe in that plane, no, right? In that rocket there, but rocket is not in a. See, coming to our point here, threading is very important. No, thread life cycle. Now come to our point here. Right. So here stop method. When we call stop method, automatically the thread will come to what there dead state. Clear? Now listen carefully. Sir, I'm fan of Varun Tej now. Right, sir. You'll put it, Bashir, right? Thank you. Fine, sir. So no comments. Now come for it. Next one is, for example, for example, what I'm telling there, just some situations I'm telling to you, understand that situations, but it may not be happen in the running race, no, but happen in threading, no, understand it, no. For example, one person participate in race, is in the middle of the running, very fastly is running, understand it, no. All of sudden, he want to take rest. He want to sleep. He got a dream of it. He want to sleep it. Then what he has to do there? That person must go for sleeping state or not? Come on, guys. That person must go for what state? No, sleeping state. When it is a case care, when he is thinking he want to go for sleeping, no, and definitely he may go for what there? Sleeping state. Okay. So now listen carefully. Don't deviate. When a running thread is available over the running thread, if we call sleep method, if we call what method, you know, sleep method with some time period, automatically that thread will come toward their sleeping state. A person is running. When a person is running, he want to go for sleeping, then he'll come forward their sleeping state. That's okay, fine. When up to how much time it will be in sleeping? No, up to how much time it will be in sleeping there? Up to the specified time, whatever the time here we specified, up to the time it will be in what there? Sleeping time. Sleep now, right? The thread is in sleeping. Now, when it will come back from sleeping state to the runnable state again, when a thread is in sleeping state, no, again it has to wait for getting the system resources. Even though time is completed, if the time is completed, system resources must be assigned. Again, memory and again, like what there, time must be assigned. Then only it is able to take the running. Got it or not? So that's why it will be in what state? No, runnable state here. Over the sleep time. Over the sleep time. Okay, it will come to the runnable state. Again, when time is assigned, automatically the thread will come to what their running state here. Okay, fine. Good. Again, the same situation. When a person is in running, all of a sudden he find his girlfriend in the gallery. He's seen what he has to do. Automatically it slow down or not? Not only slow down, it is in waiting or not? Come on, now automatically he will wait in the track or not? Right, sir. Now this is like what I'm telling there, waiting stage. This state is what there? Waiting stage. When it is the case, no, when we call wait method on running thread. Okay, again, when he will take the, when he will come back, no, when he will come back to the running state, no, runnable to running state, no, when the same heroine is saying that, yes, you can do like this, immediately will take running or not? It's going on in movies, right? And the hero isn't running seriously. All of a sudden, a gallery might be one person is identified. And then camera is going on in between that person and this person, that person and this person, no, right? Automatically slow, automatically stopped at one particular point of time. But other people are crossing their actual border, right? Then immediately she is saying that you can start immediately, no? Then immediately he has taken that. He will be the winner finally, right? When it is the case, no, observe carefully. If the thread is in waiting stage, if any other thread access notification, if any other thread is giving notification, if any other thread is giving notification, then it will take running. So if any other thread calls notify method, sorry, if any other thread access notify method, if any other thread access notify method or notify all method, two methods are available. If any other thread access notify or notify all method, automatically that thread will come to, automatically that thread will come to what state, you know, again runnable state. We can understand it clearly. Okay, the thread will come to what state there? Runnable state. Observe carefully. Notify or notify all methods. Next one. Understand it clearly. For example, a person is in running, but unfortunately he is not running. He is not taking the running and he is a track. Continuously changing the tracks. No, he is giving disturbance to other persons. The runner is giving disturbance to other competitors. Then immediately what umpire has given the call there, he is calling to this particular person like what there? Suspend. That umpire calls what there? Suspend. Suspend method. When suspend method is called, automatically that person will be in what state there? No, suspend state. Got it or not? Up to how much time it will be in suspended? No, up to some time period, up to some point. Then the umpire will have discussion with the third umpire. Okay, when the discussions are over, then the result is coming in favor of the player. Then immediately, who is that person then? Then immediately what happened there? That the same umpire will access him, will access like what there? Resume method. Resume method. Automatically, again, the runner will take running. That means if we call suspend method over the running thread, if we call suspend method over the running thread, automatically the thread will come to what state? No, suspend state. When the other thread access resume method, when other thread access resume method, automatically the thread will come to what their runnable state. No, then again it will take some time and execution time and memory, it will start running. This is one point. Next one, observe carefully, one more point. For example, a person is in running, unfortunately some groundmen are doing their work on the track. Track is disturbed totally. People are doing some work on the ground. Actually, it's not going to be happen, but assume the situation. The track is not good. Track is having some problems there. Now, groundmen, then the people went there, then doing some work. They're repairing the track. Meanwhile, what these people have to do? When the work was completed, automatically they will come back to what their runnable. Then what next one? Running straight now. Now understand it. In Java applications, when we perform IO operations, for example, your program is executing. Your program requires some input and output operation, some input operation. Whenever we are giving some input data, that thread will not continue its execution, but the thread will stay there only. Get my point on? The thread will stay there only when we are performing input operations. Right or not? Now, this is nothing but what their blocked state, temporarily blocked. This is what their blocked state. Understand it now? So different states are available. That all the states here we have to understand. First one is what there? Waiting state, sleep state, suspend state, blocked state. When IO operations are completed, over the IO operations, automatically the thread will come back to the runnable state. From runnable state to what then? Running state. Again they are running. That's it. These are the various states are available here. Understand it now? Over the running thread, if we access sleep method, sleeping state. If we access wait method, waiting state. If we access suspend method, suspend state. If we access if we perform any input operation, the thread will come to what their blocked state. Correspondingly, over the sleep time, again the thread will come to runnable state. When we access notifier method, if the thread is in waiting state, if we access notifier method, it will come back to the runnable state. Right? If any thread access resume method over the suspended thread, automatically the thread will come back toward the runnable state. When IO operations are completed, automatically the blocked thread will come back toward their runnable state. Now, these are the points here we have to understand. Then after this, after completion of which, now see, understand it how we are getting back a thread, a running thread into the runnable state. No, in these many situations, we are able to get back running thread into the runnable thread. Is it not possible to keep directly a thread from running state to runnable state? No. Understand my question? Is it not possible to keep a running thread into the runnable state directly? Yes, it is possible in only one situation, but of course that is not supported in our Windows operating system. Not supported in operating system, but situation is available, chance is available. Java has given this situation, but depending on operating system, it may be possible. No, but the point is what? When we access yield method, when we access what method here? No, yield method, automatically a thread will come from running state to what state here? No, runnable state. Running state to like what state here? Runnable state. Understand it clearly. All right, sir. This is the point here we have to understand overall. So this is overall thread life cycle. Guys, now tell me, all of you now tell me, how many states are available overall? 5 states are available. What are the 5 states now? New or born state, runnable state, running state, dead state. What last one here? No, of course, this all these states we can understand like what they're interrupted state or maybe blocked state. Blocked state we can call it as a common name, or as maybe depending on situation we can use the names here. No, right, sir? When a thread is in sleeping, that means when we call sleep method over the thread, it will come to sleep state. When a sleep time is completed, the thread will come back to the runnable state. When we access wait method, thread will come to the waiting state. If any other thread access notify all method, thread will come back toward the runnable state. If you access suspend method over the thread, running thread, automatically it will come to the suspended state. When other thread access resume method, thread will come back to the runnable state. When we perform IO operations over the running thread, automatically the thread will come to the blocked state. If we complete that IO operations, automatically the thread will come back toward their runnable state. So these are the various points here we have to understand. Right, so just 1 minute I'm telling you, and let me take this diagram as well as I want to give information about that each and every state. Now try to understand it clearly. First one is what there, new or born state. When we create a thread class object, when we create a thread class object, when we create a thread class object in a Java applications, automatically the thread will come to the new or born state. Thread will come to the new or born state. This is one point. Next one is a runnable state. Runnable state. When we access start method, system has to assign resources like memory and execution time. That is a timestamp. Okay. Here a runnable state represents the thread which is after accessing start method and before getting the system resources like memory and execution time, like memory and execution time. Right, sir? When we access start method, system has to assign resources like memory and execution time. A runnable state represents the thread which is after accessing start method and before getting the system resources like memory and execution time. Now, so this exactly this state of this thread. A runnable state represents the thread state which is after accessing start method and before getting the system resources like memory and execution time. Then that state is called as what there, runnable state here. Now, that similarly running state, here we have to understand that another one here, running state. The third one is like what there, running state. Now tell me, what is this running state? Now when we access start method, and after getting the system resources like execution time and memory, right? When we access start method and after getting the system resources like execution time and memory, the state of the thread is a running state. Right, sir? When we access start method and after getting the system resources like execution time and memory, then the state of the thread is what there, running state. Okay, fine. Next one is what there, after this, no, now third one is like what there, fourth one is like what there, dead state. When we are able to get a thread state now, when we access stop method over the running thread, then the thread state will be dead or destroy state. Then the thread state will be what there? Dead or destroy state. Next one is, after that, last one is what there? Blocked state. Yeah, here so many cases are available here that we need to understand. Blocked state. Right, sir. What is this blocked state here? Understand it clearly. Blocked state in the sense, cases are available here. Now, case number one, when we access sleep time, when we access sleep method with a sleep time over the running thread, then the thread will be in sleeping state. Then here itself I'm telling there, when the sleep time is completed, automatically, no need to call this one in this situation. When the sleep time is completed, automatically the thread will come to the runnable state. Thread will come to the runnable state. Don't say that directly the thread will come to the running state. Directly from sleeping state to running state is not possible. Why? Because first it was come for what the runnable. Then only memory and time will be assigned. After that one, it will take what the running state now. Directly it will not come back to what the running state here. Understand it now. Right. This is case number one. Case number two. When you access wait method over the running thread, then the thread will come to the waiting state. Then thread will come to the waiting state. If any other thread access notify or notify all methods, then the thread will come to the runnable state. All right. Then another point here I'm telling to you, observe carefully. When we access what method here? No, suspend method. When we access suspend method over the running thread, then the thread will be in a suspended state. If any other thread access resume method, then the thread will come back. Then the thread will come to the runnable state. The last case, no. When we perform IO operations, then the thread, when we perform IO operations in Java applications, automatically the thread will come to the blocked state. When the IO operations are completed, automatically the blocked thread will come back to the runnable state. Right, sir. Now here itself I'm giving one small note. Observe carefully. It is possible to bring a running thread to the runnable state by accessing yield method, but it is not working. It is not working on the Windows operating system. but it is not working on what their Windows operating system. Why? Because it is able to perform. It is able to perform the operations on the basis of the thread priorities. On the basis of what their thread priorities. That's it. Understand the point here? What I'm telling there? It is possible to bring a running thread to the runnable state by accessing yield method, but it is not working on Windows operating system because it is able to perform operations on the basis of what their thread priorities. Observe carefully what Windows operating system is supporting now. Windows operating system is supporting for displaying the priority values max. If you get what is the default priority value for a thread, then it is able to display. What is the initial priority value for a thread? It is able to display. What is the max priority value for a thread? It is able to display. But it will not perform any operation on the basis of priority value. For example, I'm going to give the priority value for a thread 1. If I ask the thread, try to perform this operation immediately. No, it will not do that. On the basis of priority values, it will not perform any operation in the Windows operating system. Understand my point here now? This point is sufficient to give another conclusion. If you take server-side applications or if you go for any server environment, what is going to be happen at server-side environment? No, all the operations are going on the basis of the threading. If we send a request, a thread will be created at server-side application. 10 requests if we submit it to a particular server-side application, 10 threads will be created. 100 requests, 100 threads will be created. But we need to handle all the threads now. In some situations, we have to give priority for what there some threads. So for some requests, it has to be evaluated first. After that only operations are going to be performed as per the requirement. After that only results are going to be generated as per the priorities. So definitely server-side mechanism has to do operations on the basis of priorities, on the basis of thread priorities, definitely. But if you want to perform that thread priority based operations, Windows operating system is not suitable. There we have to go for Linux or some other operating system. Because of this type of reasons only, most of the server-side applications are going to be maintained on a Linux operating system. The total servers are going to be maintained on what their Linux operating system, not unlike what their Windows operating system. Windows operating system is max what there for developers work locations only, not for this actual server maintenance. For the sake of server maintenance, we have to use what their Linux operating system only, not Windows operating system. This is one side reason that we can identify clearly. Okay, sir. Good. So overall, what we completed here, no, the thread life cycle, the total part is completed here. After completion of this thread life cycle, the next one is thread class library. Then what next point here we have to understand there? Thread class library. Thread class library in the sense, what are the various constructors which are available, what are the various methods which are available, and what are the various constant variables are available. We are going to understand about all. Got it or not? About like what the thread class library. Okay. Now let's understand this thread class library. Observe carefully. First of all, here we have to see like what are their constructors. Thread class constructors. What are the various constructors are available? What is the use of these constructors? You are going to understand. Okay. Now before that, I'm asking one question. Try to answer for it. In how many ways we are able to create threads in Java applications? Come on. In how many ways we are able to create threads in Java applications? Two ways. Two ways, not three ways. No. Two ways only. What are the two ways now? Tell me. Extending thread class. Next one is what? Implementing a runnable interface. Okay. In implementation of the runnable interface, if we take the approach of implementing runnable interface, inside this, my thread empty is equal to new my thread we created. After that, thread t is equal to new thread of empty we passed. I remember that step. In the thread class constructor, we have to pass what there? My thread class reference variable. Okay, remember at one side, remember this point here. I'm going to use that points in the future now. Right. Move on to the next one here. Now the point is constructors. What is this constructor? What are the various constructors of this thread class here? If you observe this, first one is like what there? Public thread. Public what there? Thread. All right. Now this is like what the zero argument constructor. What is its utilization there now? Understand it, kid. That's now it is able to create thread class object with the default properties. With the default properties. What are the default properties there? It will create a thread class object with the default properties. What are the default thread properties here? First one is thread name. The default value of the thread name is what there? Thread 0. Second thread if we create no, the default name will be thread 1. Third thread if we create no, thread 2. Next thread, thread 3, thread 4, thread 5 and so on. Right, this is one thing, thread name. Next one is what they offer these thread priorities. Thread priority. Default thread priority is 5. Default thread priority is what there? 5. Every thread must be under a particular group. Every thread must come under what there? A particular group. Then what is the default group? Thread group. What is the default group for the thread now? Main is a thread group. That's it. With these properties only, a thread object here we are going to create. All right, sir. Now example here I'm telling to you, understand it here. Right, sir. Now observe carefully. I want to remove this total coding part here. You want to have any punishment from my side? I'm not getting it. Dark background is not required. You want to change it? Fine. 1 minute. Definitely, as per our requirement, I will change it. You're my special student, definitely. Okay. Okay, now? All right. Answer for my question. What is the default priority value for thread? What is the max priority value? What is the first priority value? Perfect. One is the right answer. Right. Right, sir. Good. Observe carefully. So, all right, sir. Now, I'm going to take like what there class main. All right. Inside this directly, I want to prepare it. Say for example, I want to create a thread. Thread is equal to new thread. Right, sir. I have not provided any parameter here. What is that parameter? I have not provided any parameter no, that we can understand it clearly. Right, sir. We want to perform any operation or method in between running state. No. That is not possible to perform operations in between the states here. When a thread is in a particular state, then only we can perform the operations. Max, we are going to perform the operations in a running state only. Understand it here. Max start method, max. Apart from that, we are not going to perform any operations. All right, sir. Let's move to the point here. System.out.println of here what we are able to get here thread. Now say this now. Execute this one. If I execute this part here, now we are able to get some output. What output here we are able to get there? Understand it. Now a thread of this is the class for which we are creating object. For which class we created object that we provided. Next one is what there? Thread 0. Next one is what there? 5. Next one is what there? Main. So what is this thread 0 actually? Name of the thread. What is this 5 actually? Default priority value. What is the group name here? Main. Main is a group name that we are getting. Okay, fine. Now observe carefully what exactly that outputs here we are getting. This is a program. All right, sir. Now I want to take this program. Now outputs also here we are getting there. This is an output. Okay, fine. Now this the second constructor here I want to provide public listen carefully. Public string, public string, string name, public thread string name, public thread string name. Now, what it will provide there? It will create a thread class object. It will create a thread class object with the provided name, with the provided thread name. Previously, we got the thread name is what there, thread 0. But this time I want to provide a particular name. I don't want to have what the name. I don't want to have thread-0, thread-1. This format I don't like it. I want to provide a particular name. All right. For that purpose, we are going to use this particular constructor. Now let me check it. Inside the constructor, now inside the thread class constructor, I want to pass something else like what there, core Java. I want to provide this. For example, name of the thread is what there, core Java, that I'm trying to provide. Now let me execute this. Now here, what we are getting the name of the thread here now, core Java is the name of the thread here we are getting. Okay. Right. So another example. Now at the same time here we are having output here. Okay, fine. Next one is the third one. Third constructor here we are understanding. Public thread of runnable interface. Public thread of runnable interface. Then what is the purpose of this particular one? It can be used to create a thread class object. It can be used to create a thread class object with the runnable reference. With the runnable reference. Understand it here. Now, direct advantage we are not having. No changes in our output there, but this will allow us to create second approach of creating threads. It will allow us to create the threads in a second approach. It will be used in second approach of creating threads. That is by implementing runnable interface. But it is not giving in this context. It is not giving any variation in our output here. Understand my point now? So it can be used to create a thread class object with the runnable reference. Okay, fine. Now let me check it. You have to give information to me. For example, runnable is equal to, tell me, all of you now tell me, new thread. Is it possible? Is a statement is possible now? Tell me. Runnable is equal to new thread. Is it possible? That means runnable is an interface. Thread is what their class. Do you have do you have any relation between runnable interface and thread class? Is there a relation between these two? Yes, we have a relation between runnable and thread. Thread is an implementation class to runnable interface. Thread is what there? An implementation class to runnable interface. Now tell me, is it possible to assign implementation class object reference values to the interface reference variables? Is it possible to create objects for implementation class and declaring reference variable for interfaces? No. Yes, right from whoops onwards, object orientation onwards, we have seen that. We can create objects for what? We must create objects for what? Implementation classes only. Not possible to create object for what? Their interfaces. No. We can create object for implementation class. We can declare reference variable for what? Their interfaces. That is possible or not possible? As possible. The same thing here I'm doing. No. Runnable is equal to new thread. Why? Because thread is an implementation class. Runnable is what? There an interface. No. All right, sir. Now here after this, now what I'm telling now, to the thread class constructor, directly to the thread class constructor, directly here we are passing what there? Runnable reference. What reference can we pass there? Runnable reference. In our output point of view, no changes. No. In our output point of view, no changes are going to be happen. Now see this one. But thread name will be changed. What should be the thread name now? Guess it. What is the thread name here? I have not provided any thread name explicitly. So what value we are able to get now? Thread-0, thread-0. But actually thread-1 we are able to get. Why thread-1? Already one object we created or not? Thread-0 is the name for this first object. Now second thread object here we are creating or not? The second thread object is what there? Thread-1. Got my point or not? So in our output, what data we are trying to display? Thread. Thread is referring what object? No, first object or second object? No, second object. So the name of the thread is what there? Thread-1. The remaining properties 5 comma main, both are same, all are same. No need to have any content about it. No need to have any like doubt about it. No, then it able to provide what value here? No, thread1. Thread1 is a value here it is providing. Why? Because the second thread object here we are creating, not first thread object. For thread class we are creating second object. Thread 0 is the first name for the first thread. Thread-1 is what there? Second name for the second object, you know, that we have to identify. Okay. Now here I am going to provide like what there value here I want to provide. Now after this I'll go for another constructor. What about this another constructor here? Fourth constructor public thread of runnable or comma string name. Two parameters here we passed. What are the two parameters here? No, first one is what there runnable. Next one is what there string. Then what it is able to do now? It is able to create a thread class object. It is able to create a thread class object with the provided runnable reference and the thread name Right, sir. No direct advantage with this particular content, but we are able to provide a name, a particular name. At the same time, we are allowing to create a thread in a second approach. That is by implementing runnable interface approach. Now, okay, inside this, what I am telling now, runnable reference here we pass it here. Then after that, here we are going to pass like what there another parameter. So core Java is like what there name of the thread that what we created clearly. Now let me execute this. There we are able to get output directly. Core Java in place of thread1, what we got there? Core Java 5 main. Like this here we are getting some output. Okay. After completion of this one here, another thing is like what there? For example, say this one. Fifth constructor public thread of thread group, public thread of like what there thread group. Yes, sir. I'll forget my point or not. Thread group comma string name. What is the purpose of this particular constructor? It can be used to create a thread class object with the provided thread group name. You are going to provide thread group name in the form of like what there thread group reference comma name of the thread. Okay, it is able to create a thread group thread class object with the provided thread group name and the thread name. Now okay, example code is like what I am telling you. Runnable is not required here inside this thread group is equal to new thread group name I need to provide. Say for example main is a default name for it, but this time I want to provide what the Java is a group. Java is what their thread group name. Next one is thread is equal to new thread of there I want to provide first one is what their thread group comma what next one you know I want to provide name of the thread core Java thread is equal to new thread of thread group comma core Java. Now system.out.println of here we have to provide what their thread reference here we are providing. Now tell me what output we are expecting now. What is the name of the thread here? Core Java. What is the priority value? Default priority value, that is 5. But what is the thread group name? Java. Java is a thread group name. The thread group name here we are able to get. See this output here. Now thread core Java 5 Java. This values here we are getting. Now the output value here we can identify. Next one after that. Next one is another constructor public thread of thread group tg comma, then after that runnable reference combination. Previously we provided what their name along with the thread group, but this time we are providing what their runnable reference, not name. Still the name of the thread is what their thread 0 only, thread 0 or thread 1, these names only, but extra we provided what their runnable reference along with this particular thread class constructor. It is able to create. It is able to create thread class object. It is able to create what the thread class object with the provided runnable reference and the thread group name. Again, I'm telling there, its direct advantage is not available, but it can be used to create the threads in the second approach by implementing runnable interface. That only the advantage, that only the point here we have to understand. Right, so now let me take this example here. Now, here what we are having a thread group is available. After this thread group, next one is what there runnable. Runnable is equal to new thread. Now here thread group. After this thread group, instead of this name, now here we have to take what the runnable reference. Now tell me what outputs here we are getting there. Now tell me from this program here. First of all, what is the name of the thread? Name of the thread is what? Is it thread 0 or thread 1? Thread 1. Why? Because second object we are created there for this thread class, no? Thread 1. The next one is priority value is same 5. What is the thread group name? Java. Java is what there? A thread group name. Let me execute this. Now thread 1 we are getting, then 5 Java. That outputs here we are getting. Right, sir. So this is like what there thread group tg comma runnable r that we are getting. So now observe carefully the last constructor. Now overall all parameters here we are going to pass. What are the all parameters here? Thread of first one is what there thread group tg comma. Next one is what there runnable or next one is what there string name. The same point it's able to create a thread class object. It's able to create a thread class object with the provided thread group name, provided thread group name, comma runnable reference, and with the provided thread name and the provided thread name. Okay. Now example code, just we are able to provide all. Thread group is ready, runnable is ready, thread group and runnable we provided. Now here we have to provide what their name of the thread only here we have to provide. Now session output bundle of thread, there we are able to get the same output. Whatever the output we are getting at present, the same output we are able to get. But in place of thread 1, we are able to get what name, core Java we are able to get. Apart from that, we are not having any changes over the code. But flexibility, multiple parameters here we are providing. It means that it is providing what their flexibility while creating Right. Depending on our requirement here, we can provide this. Right, sir. These are overall the constructors what you are having inside the thread class. What content is available, sir? Here we are getting like what there constructors. All constructors here we completed. Got it or not? All right, sir. Now it's okay, fine. Now this is completed. Constructors are completed. After completion of these constructors, now here we have to talk about what their methods, thread class methods, thread class methods. Right, sir. Now can I discuss this topic on tomorrow? Right, tomorrow what will be the time for it? 7 o'clock. Today I have seen the results. Very good results. Huh? Okay, then even if I come here, then people are not attending the classes now at 7 o'clock or 7:30. Today I came here at 7:20 or something else. No, but I think at what time? 8 o'clock. Huh? Okay, whatever it may be. 7 o'clock it may not be possible for you. I understood that. Okay, now come at 8 o'clock tomorrow. 8 o'clock, okay, no problem. 8 o'clock is not early morning, sir. 3 o'clock, 4 o'clock is in early morning. 8 o'clock is already day started, might be before 2 to 3 hours back. Okay, so 8 to 1 o'clock. Our target is what we have to complete multi-threading totally. Remaining what topics are remaining there inside this multi-threading? So thread class methods we are going to see. Very good methods we are going to see. Very daemon threads we are going to see another topic. After completion of the daemon threads, next one is what there thread safe resources topic where we are going to see synchronization. After that inter-thread communication. After that deadlocks. Next one is a thread local. So these are thread scope. These are overall 3 to 4 topics are available. So our target is we have to complete all 3 to 4 topics now. But that depends on your cooperation only. If we come at exactly 8 o'clock, I'll start by sharp 8 o'clock. By 1 o'clock, we are able to complete it. If we complete it, and then next day onwards, we are going to start directly what there IO sims. If I complete IO sims, no, the next topic will be collection framework. Yeah, that is the most important topic in core Java along with object orientation. Both object orientation collection frame both are important topics now. So after this multi-threading, we have to plan for what there IO streams. After these IO streams, we have to plan for what there collection framework. If a complete collection framework, think of it, your 90% of the syllabus is going to be completed. The remaining 10 maybe Java 8 features is another content lambda expressions. But of course, we are going to have classes up to Java 20th version. No second thought. Even though if I take some time here, but I'll complete the content by with the Java 20th version features. But important topics I'm telling there. Next important topics are IO streams. Next one is what their collection framework. After that, Java 8 version features, especially stream API and lambda expressions. They are the remaining important topics now. But depends on your cooperation. Tomorrow, come here by 8 o'clock. Then we'll plan for it to complete this total content. The Monday onwards, we'll plan for what their IO streams. Yes, sir. Got it now. Okay, right. Take some break and come back now. I'll start advanced Java classes.